Yeah, welcome students. Welcome back. So welcome to my channel. Today I am going to discussing the topic is continuity. Yes. What is continuity of a function? Yes, come on. Let f be a function. So defined on neighborhood of a. Defined on neighborhood of a. Okay. Then what is the continuity of a function? F is said to be a continuous function. Limit x tends to a, f of x is equals to f of a. Yes. What is the condition? Limit x tends to a, f of x is equals to f of a. Then you can say f is a continuous function at the point x is equals to a. Yes, when you can say the function is a continuous function at x is equals to a, here please observe this one. Limit x tends to a, f of x is equals to the f of x value at x is equals to a. If these two are equal, then you can say the function is continuous at the particular point x is equals to a. Yes, and here one more thing, please observe on left hand side. Limit x tends to a. When the limit exists, first of all, when the limit exists, this limit is exists when limit x tends to a plus f of x is equals to limit x tends to a minus f of x. Can I write like this? That means which is the right limit of the function and the left limit of the function. This is equals to f of a. That we can write in this way also. Right? This is the way of finding the existence of the limit. When the right limit is equals to left limit, then only the limit will exist. Right? Then limit x tends to a, f of x will exist. If this is equals to f of a, then I can say f is a continuous function at x is equals to a. Suppose in these two values, if one of the value is equals to f of a, I mean like this. Suppose if this is limit x tends to a minus f of x is equals to f of a, then I can say this is the only left continuous at x is equals to a. What you say it is? It is left continuous at x is equals to a. Suppose if limit x tends to a plus f of x is equals to f of a, then I can say f is right continuous at x is equals to a. Okay. First of all, when the limit exists, left limit is equals to right limit, then only the limit will exist at that particular point, and this limit is equals to the value of the f of x at x is equals to a. Then we can say the function f is continuous at that particular point. Okay. So this is the definition of a continuous function. Okay. So let us see some examples for the continuous function. Yes. So let us see some examples. So which are continuous functions. Okay. So the function f of x is equals to constant. F of x is equals to constant. I mean y is equals to constant, which is always a continuous function. Okay. Let us see the continuity function. By graphically, I will explain this one. F of x is equals to constant, which is y is equals to constant. If I am going to take the graph, okay, so y is equals to k, which is parallel to x-axis. This is the line y is equals to k. Yes, graphically, how can you decide this one? Whether it is a continuous function. If you are going to draw the graph of the given function, so for this function, you may not get that any breaks. Continuously, you are going to draw. Yes, like this. Then you can say it is a continuous function. Yes, so one more function, f of x is equals to x for all x belongs to R. Okay, f of x is equals for all x belongs to R. Yes, it is a continuous function. Y is equals to x, which is always passing through origin. Right? Graphically, I can decide that one. It is a continuous function. For in this graph, there is no breaks for this one. Right or not? Yes, and f of x is equals to sin x. F of x is equals to cos x. F of x is equals to any rational function where the functions are defined on their domain. There are always continuous functions, some standard continuous functions. Okay. Yes, let us say I will explain some more examples which are not continuous, and I will give the reason. Okay. Yes, let us see. Suppose f of x is equals to sin x by x at x is equals to 0. Is it continuous? Particularly I am asking at one point f of x is equals to 0 is a continuous or not? Okay, yes, come on. Now actually what is the continuity definition? Limit x tends to a, f of x is equals to f of a, right or not? X tends to a, f of x is equals to f of a, x is replaced by a, then we can say f is a continuous function at that particular point a. Here like you can see this one, limit x tends to a. Now this one is limit x tends to a, f of x. So here particularly my point is 0. Limit x tends to 0, f of x. That means limit x tends to 0 sin x by x, whose value is 1. Okay, and coming to f of 0, sin 0 by 0, sin 0 by 0, which is 0 by 0, not defined, right or not? Then what do you say? The function f of x is equals to sin x by x is not continuous at x is equals to 0. That means I can say f is, the function f is discontinuous, at x is equals to 0. Like this, we will check these problems. Okay, yes, so come on, we can see some functions. F of x is equals to modulus of x. F of x is equals to modulus of x. Just check the graph of the modulus of function. This is modulus function. Okay, so f of x is equals to modulus of x, which is always continuous, where this function is defined. I mean, on its domain it is continuous function. Okay, and f of x is equals to step of x, greatest integer function. Greatest integer function is always a continuous function at the r minus z. Am I right? At all the real numbers except z. Let us see graphically. You know this one, step function. Okay, yes, coming to this one here, 1 2 3 4, 1 2 3 4. So when x value lies between 0 to 1, what is the step of 0 is 0. This is the graph of the step function. Okay, here like this. Am I right or not? Okay, that means excluding the values. At x is equals to 1, its value is 1. Up 1, 1.2, 1.3, 1.4, up to 2, its value is 1, like this. So which is your step function. Okay, yes, clearly you are observing this one. For the step function, I mean greatest integer function, this graph of the step greatest integer function, you are going to getting the breaks at the integers. Am I right or not? Between 1 and 2, it is the graph is continuously going, but at x is equals to 2, its value is 2. 2.1, 2.2, and again it is continuously going at that particular point, and again it takes the break like this. So I can say f of x is equals to step of x is continuous yet all the real numbers except the real number, except the integers. Okay, yes, I think you understood the concept of a continuity function. Okay, yes, come on, let us see some problems. So which we got from the previous years, MAINS and Eamcet. Yes, f of x equals to ax plus 3 if for x less than 3, and one more condition, 3 minus x plus 2x square if x greater than or equals to 3. It is continuous on real numbers. What is the value of a? Yes, first of all, it is continuous on real numbers. So if any function is continuous on its interval, it is continuous at every point. It is continuous at every point on that which it is defined. That means here real numbers it is defined. Okay, yes. So clearly here defined at x is equals to 3. So clearly they have given at x is equals to 3. I am going to take this one. Why? Because 3, one of the real number. Okay. Yes. Now I can take, since f is continuous on r, that means at x is equals to 3 also it is continuous. Now I can take this one, limit x tends to 3, f of x is equals to f of 3. Am I right or not? Limit x tends to 3, f of x is equals to f of 3, which is your continuous function definition. So here clearly they have given that left limit of 3 and right limit of 3. Yes, come on. This means limit x tends to 3 plus f of x is equals to limit x tends to 3 minus f of x is equals to f of 3. Why? Because here they have given it is clearly continuous function. That's why I am going to equating. Come on, 3 plus f of x which is greater than or equals to 3. This is the function when x is greater than or equals to 3. Come on, substitute this one which is 3 minus 3 plus 2 of 3 square. Yes, so which is the right limit. 3 minus f of x, which is a times of 3 plus 3, which is equals to f of 3. Yes, it is greater than or equals to 3 also. Yes, what is this value? Which is 3 minus 3 plus 2 times of 3 square. Right? So I think both are same. So which value is 3a plus 3 equals to, which is 3 square, 9 to 18. Okay, 3a is 18. Yes, 3a equals, which is 15. Then a is equals to 5. That's all. This is the problem. Okay, come on. Yes, yes. So coming to one more problem. F of x equals to 4x minus 1 whole cube by sine of x by p to logarithm of 1 plus x square by 3 base a. This is when x not equals to 0. I mean x tends to 0. When x tends to 0, this is your f of x. And when x is equals to 0, the value is 12 into log 4 whole cube. And it is a continuous function at x is equals to 0, clearly given. At x is equals to 0, it is continuous. Then what is the value of p? So clearly I am going to write is continuous at x is equals to 0 means limit x tends to 0, f of x is equating to f of 0, which is your continuous definition. So f of 0 value already given. So now I am going to find x tends to 0 f of x and equating to this value. Yes, come on. So which is limit x tends to 0. So 4x minus 1 whole cube. Okay, by which is the sine of x by p. Okay, so which is the logarithm of 1 plus x square by 3 base e. Yes, coming to that, our standard formulas of in case of limits, limit x tends to 0, a power x minus 1 by x is there, then there will be a standard formula. Okay, and whole cube is there. Okay, yes, now this I am going to write limit x tends to 0, 4 power x minus 1 by x, dividing with x and multiplying with x. So but here cube is there, that's why dividing with the x cube and multiplying with x cube. Okay, and remains as is by this is sine of x by p into logarithm of 1 plus x square by 3. Okay, so here limit exists, there is no problem. And when limit x tends to 0, what about this one? Sin x by p by x by p, then only its limit exists. And the limit x tends to 0, log 1 plus x by x, then only limit will exist. So, but here the terms are not there. Yes, and again, I am going to multiply and divide with this one. Okay, yes, now in the next step, okay, this exists, this is already completed. Now, this can be written as limit x tends to 0, the first term as is 4x minus 1 by x whole cube, and x cube can be written as x into x square. Yes, let us see, x into x square by, so it is a sine of x by p, right? Sine of x by p by 1 by x, I mean, right? And it is logarithm of 1 plus x square by 3. Now here multiplying with 3, dividing with 3, am I right? Multiplying with 3 and dividing with 3. Okay, yes. Now what is your answer? Come on, let us see now applying the limits. Now total it is limit x tends to 0, a power x minus 1 by x, log a base e, am I right? So this value is log 4 base e whole cube, right? And the limit x tends to 0, x by sine of x by p is, which is 1 by p, in the denominator 1 by p, thus this value is p. Okay, and what about this value? Logarithm of 1 plus x square by 3 by x square by 3, which value is 1 with 3 is 3. So this is your problem. Okay, so this is the value of limit x tends to 0, logarithm of 4 base e into 3p. But actually what they have given? This value they have given. So which is equating to this one. So in place of 3p, here 12 is there. That means 3p is equals to 12, p is equals to 4. That's all. This is my problem. Come on, make a problem. F of x, they have given the 3 conditions. F of x is 5 when x less than or equals to 2. which is ax plus b. X lies between 2 to 10. X greater than or equals to 10 when f of x is 21. Is continuous on R. Is continuous on a set, real number set. That means which is continuous at each and every point on the real number set. It is at 2 and at 10. In that case, what are the values of unknown variables A and B? Yes, come on. Now, can take like this. F of x is continuous on real numbers. Now, can I take at x is equals to 2? At x is equals to, can I take like this? That means now, according to that, the definition of continuous, limit x tends to 2 plus f of x is equals to limit x tends to 2 minus f of x is equals to f of 2. I mean the limit will exist when right limit is equals to left limit and which is equals to the value of x at x is equals to 2. Yes, come on. 2 plus x greater than 2 whose value is, this is a times of 2 plus b equals to 2 minus less than 2 whose value is 5. Of course, f of 2 also less than or equals to 2 which value is 5. Then I got one condition, 2a plus b equals to 5. Yes, and one more is there from this one. X less than 10, x greater than or equals to 10. Yes, can I take like this? So f is continuous on real numbers. So I can take at x is equals to 10 also, it is continuous. Right, come on. This means limit x tends to 10 minus f of x equals to limit x tends to 10 plus f of x is equals to f of 10. Come on. 10 minus f of 10 minus less than 10 whose value is a times of 10 plus b. A times of 10 plus b equals to 10 plus f of x. 10 plus greater than 10 whose value is 21. Okay. Yes. So then this means 10a plus b equals to 21. I got one more condition in terms of a and b. Yes, come on. Now solving this two, which is 2a plus b is 5. Okay. Then subtracting this one, which is 8a is equals to 16. Then a is equals to 2. If a is 2, so here the b value is 1. This will be the problem. Come on. So which is a continuous function. First of all, what is the basic form for the continuous function? F is a continuous at a point. The limit of the function at x is equals to that point is equals to the value of the function at x is equals to 2, of course. Then according to proceed that, we'll get the value. Okay students, come on. Yes, let us see some problems for discontinuity. Find the number of discontinuous functions y equals to f of x, which is defined on minus 2 to 2, closed interval minus 2 to 2, which is satisfying the equation of us. Okay, x square plus y square is equals to 4. Okay. Yes, let us see. Between the interval minus 2 to plus 2. So number of discontinuous functions. So let us take, I am going to take one point alpha in between the interval. Alpha belongs to minus 2 to plus 2. Now can I define like this? Equation of S. Okay. Okay. Equation of S. Okay. This is. So when alpha in between that interval minus 2 to plus 2, I am going to take one value. Okay, so here this value I am going to define like this: y is equals to square root of 4 minus x square, right? When alpha belongs to minus 2 to 0, right? When alpha belongs to minus 2 to 0, I'm sorry, minus 2 to alpha. Yes, and which is minus square root of 4 minus x square, right? When this x belongs to alpha to 2. Okay, yeah, like this we can define so many functions, so many infinite discontinuous function which are on this function. Okay, yes, and coming to one more problem. Come on students, is it okay? Come on, make a note. And coming to the next problem, one more problem is there. Yes, coming to this problem. Number of discontinuous points. F of x is equals to 1 by x square minus 17x plus 16. Find the number of discontinuous points for f of 2 by x minus 2 when it is discontinuous. Okay. Yes, first of all, f of 2 by x minus 2. This function can be, yes, it's defined when x minus 2 not equals to 0. So x not equals to 2. Am I right or not? So at x is equals to, it is not defined. And let us take it is equals to t. For this function we are going to find. And here coming to this one. So f of x is a rational function. This denominator should be not equals to 0, which is x square minus 17x plus 16 is not equals to 0, right? And this is x minus 11 into x minus 6. Okay, so I think it is 66. Okay, so which is not equals to 0. So x not equals to 11, x not equals to 6. Okay, now they are asking about what are the discontinuity points. Now I can take like this. So this is 2 by x minus 2 is equals to 11, right? 2 by x minus 2 is equals to 11. Then 2 is equals to 11x minus 22. 11x is 24. X is equals to 24 by 11. And this 2 by x minus 2 is equals to 6. This 2 is equals to 6x minus 12. Okay, and this is 6x is equals to 40. X is equals to 7 by 3. Yes, let us see what these values are. At these points, the function is a discontinuous. What are the points? X not equals to 2. I mean, at x is equals to 2, it is a discontinuous. At x is equals to 7 by 3, and at x is equals to 24 by 3. Right? Come on, make a note, students.